there, Tomasz is here from Easy Automator. By today I have a pretty complex task for you, which I would like to show you, and this is how you can use with the Easy Automator tool a remote TCP recording. What does it mean, remote TCP recording? This is pretty easy if you know what you are doing. Normally we have a kind of tool on the robot, and this tool will be moved around. You can spray, you can grind, you can weld, you can do everything what you want. But what happens if you have a very complex and big statical installed tool, like a grinding machine, a big one, and you want to move around your workpieces around this grinding machine? So especially for these cases, we developed this feature to do this with the so-called remote TCP. And by today, I would like to show you how you can install and implement it step by step. For the very beginning, I don't have a big grinding machine, and I don't have any big machine to show you how it works. So this will be my tool, the big grinding machine, okay? And with this tip, I'm just, this is a kind of symbolic TCP, one characteristic point on this grinding machine. For sure, if you are doing so, then you really have to figure this out, how you can define this point on your machine in any kind of way for this setup. This must be fixed because this is a very crucial part of the story. But once you manage this, this will help you a lot, that you can really reach your goal. So exactly on this point, you will be able to move around the workpiece and you can do any kind of tooling. So let's start. I come to the PC, and just to make it very clear, this is not a typical cobot application. So this is completely clear for us, but I have right now this Elite robot CS63 on hand. This is a small one. And for this demonstration, I will use this cobot. I think you will be able to understand what we are planning and what we are doing with this. So for this reason, as mentioned, I'm just downloading from the RobotDK station or library the CS63 from Elite Robots. I just hit open as usual, and bam, here we go. We already have this. I have to define a tool at the very beginning. This is my tool, this tip. So I just define it, add a tool TCP, and I just rename it tip. Normally, you can go ahead with the define TCP tool, which is built in RobotDK. I will give you the link. For this, we have already ready to use video in our tutorials. I don't want to make it step by step through because it doesn't make any sense. I know exactly that this TCP is 0050 because we 3D printed. So this is an easy going for me. I just save the file, and we call this station remote TCP tutorial CS63. Okay, all right. As next, we have to define a frame for the Easy Automator tool. You always need a frame to use with. So I will use the wooden plate, what we are using all the time, and I will calibrate this wooden plate as a frame for the next steps. So what I'm doing, I'm just adding the frame. I just rename it wooden plate, and I just hit define reference frame. So as usual, we have the ready to use video, but I will do this for you here. I'm just selecting the right position. Very crucial, we are using the joints. The robot is the right one. The tool is the right one as well. So I'm just in local mode on my Elite robot, and I'm just coming to the origin position. The last millimeters, as always usual, I'm just doing it with the jog mode. For this, I reduce the speed. And to make it clear, I'm just coming down. And I have a lucky day, guys, because it was pretty fast. So I'm just switching back to the remote mode. And this is why I'm always recommending you to use the driver in RoboDK, because then I don't have to write down all of the coordinates, but I can just connect my cobot. In this particular case, I know the IP and everything, so I don't have to bother about, I think this was the 5. The port is 3001. And if I hit the connect, yes, here we go. The robot has already exactly the position on my screen, as you can see, as in the reality. Yeah, you can make it sure hitting the get position, and then you will see that this is the right position. So the P1, I'm just get this position. And the next step is to go to the X direction. As usual, I have here X direction, X positive, Y positive. So the next one, I'm just coming up. I try to keep the orientation as well as far it's capable. Okay, and the next, as usual, the last millimeters, we are just jogging. Okay, guys. So for this exercise, I'm satisfied with. So this will be our X axis. Right now, I'm just hit get position. You can see on the screen that the robot position, the coordinates were read out one by one. And I'm just hit get P2. And here you can find the joint values for this. So the third one is the Y. And I could use any point on the surface, but I'm going to or define Y position, because then this is how we normally use and recommend it. So, and we just hit the get position. It's done. And get P3. So you can see the frame error is 1358 millimeters. I just update this. This is for me good enough. And before we go to the next step, I always recommend you to do this. You just simply come back to the 0 position, or approximately into the 0 position, to test out if the 0, the origin, is really the origin. So here you have the chance, without any additional pain, to see if we are approximately on the right position. For this, we just select our robot with F3, and instead of the base coordinate system, we are just selecting the wooden plate. And here you can see right now, wherever I have the tool is -1.8, 200 and 0, which is a little bit annoying for me, because I was expecting to have here 0, 0, 0. What I was doing wrong. Even the frame is the right one, the tool is the right one. 0050. Okay, wait a second. Yeah, okay, that makes sense. So for sure, I have to read out the position first from the robot, and then I have the right coordinates on this. So you can see here, for sure, I have 1 millimeter offset in the Z axis, but it doesn't matter for me. I don't want to make it below 1 millimeter accuracy. I just want to check this out, if the coordinates are approximately, if this calibration, this definition of the frame is approximately the same one. So I'm just coming to the X, get position, and here we see approximately 300 minus 10. It seems to be just perfect for our purposes. Okay, so right now we are ready with the configuration in terms of our tool and in terms of our frame. And the next setup is we will define the TCP of the remote tool. This is the next what we will do right now. I just make a very short break on this, and then I'm coming back and I show you how to make the TCP definition on the remote tool.